Hello, students. Today we'll be working on Notes 10, where we will be factoring using the techniques that we've been using, but finding out that there are sometimes greatest common factors or other special products that happen. So our first problem, we have 2x to the third minus 26x to the second minus 60x. So one tip off might be that you have an x to the third. The other is that all of your numbers are even. So before determining A, B, and C, we need to divide each one of these terms by the greatest common factor. So we can divide each of these by a 2x, and in doing so, we'll have a 2x, and then actually, I think I'll go ahead and just write it underneath. So 2x, and then starting a parentheses, doing the dividing, x to the third divided by an x would have an x squared. Your 2's would cancel. Negative 26x squared divided by 2x would be negative 13x. And then negative 60x divided by 2x would be negative 30. Once you have this, then remember that if you have a common factor, it's a good thing to go ahead and either type that into Alex or write it in your answer blank. Now you can identify the A, B, and C. So A is a 1, B is negative 13, C is negative 30. So we'll go to our chart. A times C is negative 30, and your B is negative 13. So thinking about what multiplies to 30, we have 1 and 30. We have 2 and 15. We have 3 and 10. And we have 5 and 6. Now you have two candidates that could somehow be made to combine to 13. So you have to pay attention to the fact that you need a negative 30 and a negative 13, meaning that the signs are going to need to be different, and the candidate that works with that is 2 and negative 15. So 2 plus negative 15 will give me my negative 13. 2 times my negative 15 will give me negative 30. So this is the pair that I want to use. Going back to my problem, I'll have my x squared and then plus 2x minus 15x, and then bring down the minus 30. Now, we don't want to forget the 2x. You can just draw an arrow down to remind yourself to put that in. We'll do a cut line. We can divide both of these first terms by x, leaving us with parentheses x plus 2. So again, we divided both of these by an x. And then our last two, we can divide both by negative 15. So that would come down, and that would leave us with the parentheses of x plus 2. So x plus 2 is one of our factors, along with the x minus 15. Now, as you write your final answer, you want to include the greatest common factor. So you want to include the 2x and the x plus 2 and the x minus 15. So all of that would be what you would type in for your final answer. All right, so there's an example of something that has a greatest common factor, and you will need to be sure to look for that. If you don't look for that, you might have bigger numbers to work with and then have to factor it out at the end. All right, your second example is 4a to the second plus 12a plus 9. As we look at this one, there is no greatest common factor. So we can go ahead and identify the A, B, and C. So A would be the 4, B would be the 12, and C is the 9. So we would need to see what multiplies to 36. That's your 4 times 9. And what adds to give us 12. So as we think about 36, we've got 1 and 36. We've got 2 and 18, 3 and 12, 4 and 9, and 6 and 6. All of these will multiply to give us 36. But only one pair will add to give us 12, and that is the 6s. Now, I might tell you that if you get a very large number for your multiply, you might try doing a square root, because often it is doubles that that will be used when you get those really large multiplies. All right, so we'll write down our 4a squared, and then use the pair that we found. So plus 6a plus 6a, and then write down our last term plus 9. We'll do the cut line. Dividing, now we can divide by 2a on both of these. So 2a is written outside of a parentheses. 4a squared divided by 2a will give me 2a plus 3. And then I can divide by a 3. So remember to write that down and then start a parentheses. So 6a divided by 3 is 2a plus 3. So notice that I have that matching parentheses of 2a plus 3. And then I can mark it out. And my other parentheses is the 2a plus 3 from the outside. Well, notice that those are both the same. And so that is your final answer. Or you can write it as a parenthesis squared. So we can write it as 2a plus 3 times 2a plus 3. You do have to have both of them. Or you could write it as 2a plus 3 to the squared power. So that's what we call a perfect square trinomial. When you have a perfect square trinomial, your final answer ends up being a parentheses that you could raise to the second power. So again, this is a perfect square trinomial. Okay, we'll move on. We'll take a look at problem number 3. So for this third problem, we once again have a greatest common factor that we can divide out. Each one of these has a 3 that can be divided out, but not a variable. So we can divide out a 3 And then in our parentheses, have 3x squared minus 22xy plus 7y squared. So our A is 3. Our B is negative 22. And our C is 7. So when we move to the chart, A times C, 3 times 7 is 21. And our B is negative 22. So we'll need to think of multipliers to 21. So that'll be 1 and 21 and 3 and 7. The pair that we could make add to negative 22 would be if we make both our terms or both our factors negative. So if we have negative 1 times negative 21 and negative 1 plus negative 21, we'll get our negative 22. Now the difference in this problem from a previous one is that we have two variables. So I'm going to go ahead and draw an arrow down and put my greatest common factor of 3. And then I'm going to write in my parentheses here, I have 3x squared, then minus 1. Now I have an xy, so both my middle terms need to have that xy. And then my other number was minus 21. It also needs to have xy. And then plus 7y squared. So I can do the cut line, and I'll be able to divide both of these by an x, so that when I do, I'll have 3x minus 1y. So my next term I can divide by, now it's negative, I have a negative 7y that I can divide by. So negative 7y, and that will divide and give me 3x minus 1y. There's my matching parentheses again. So 3x minus 1y would be one of my factors. And the other factor is the x minus 7y. And so when you write your final answer, you'll have your greatest common factor of 3, and then you'll have 3x minus, now I've been writing 1y, but really you could just write y and then x minus 7y. So you may have some problems that have two variables. You need to make sure that your middle terms have those two variables in them. And then we have one last example. So example number 4. Now this one has two terms, so we're not going to split the middle on it. We do need to notice that we have a common factor. We want to divide by a 2, but they also have z to the second power. That is a common factor. So we can divide both of these by 2z to the second power. And so the 2z to the second power would be written outside of a parentheses that has, so doing my dividing, 8 divided by 2 is 4. Z to the 4th divided by z squared will be z squared minus, and then my z squareds will cancel. 50 divided by 2 is 25. Now, this is from homework 9, so we have to do the square root. The square root of 4z squared So the square root of 4z squared will be my a. And so my a is 2z. And then b, the b is the square root of the 25, which is 5. So I'm going to go back to using my formula of a plus b times a minus b. So I'll have, for my a, I'll have the 2z, and then plus 5. So let's see if I can write that a little bit better. 2z plus the 5. And then I'll have another parentheses, and that'll be 2z, and then minus my 5. Now, I want to remember that at the beginning of the problem, I divided out a 2z squared. So I need to remember to draw an arrow or something so that I remember to put that in with my answer. So my final answer, 2z squared, and then 2z plus 5, and 2z minus 5. So you're going to have a variety of problems where they might have common factors, where they might have two variables, or where they might come out as a parentheses squared. So you'll have this class to work on this, and we have a quiz next class. Good luck with your homework, and let us know if you have any questions.